Today I am going to discuss a very interesting as well as very important topic of data mining of late, which has found huge business applications. The name of the topic is market basket analysis and discovery of association rule. The presentation will have the following outline. I will discuss about, or rather introduce, what is market basket analysis. Then I will discuss what are association rules. Then three concepts, important concepts: support, confidence and lift. These three will be introduced. And then we'll discuss very briefly how the R programming language can be used in discovering or mining association rules, so that a practical flavor of this theoretical framework can be given. Okay, I start with the topic by introducing a typical market basket. A customer visiting a shopping mall usually comes out with a bag of different items. So in this shopping basket, the illustrative example, we have the shopper purchased a quart of orange juice, some bananas, dish detergent, some window cleaner and a 6-pack of soda, right? And let us start our discussion using this imaginary market basket and ask few questions. How do the demographics of the neighborhood affect what the customer buys? Okay, this question, important question, and we have to address this kind of question. Is soda typically purchased with bananas? Does the brand of soda make a difference? Okay, then what should be in the basket but that is not there right now? That means whether the customer is making an informed purchase or there are some thing which he or she could have purchased to maximize his or her gain or value out of this purchase. Are window cleaning products purchased when detergent and orange juice are bought together? So these are intuitive questions which probably we do not answer sometimes, but market basket analysis will give us a framework or an insight how to analyze and get suitable answers out of these questions. Okay, so those questions will be addressed, but before that let us have idea about what are the issues market basket analysis actually wants or attempts to address. Find out what are the things which are bought together. Okay, design cross-selling strategies, optimize shelf layout. So this MBA in retail will help in answering or addressing these issues. Okay, timing of the promotion schemes, then how to make a good planning about the discount strategies, price discounts, product selection under limited space. So you have got a limited space in the your shopping mall. So what are the products you should ideally select to be there in the shopping mall or in the shop? Targeted advertisement and personalized coupons. That means how to get best out of these kind of strategies. So these are some. I am not claiming that these are the exhaustive list of work that can be addressed by MBA, but these are few things which can be very well addressed. Now there are market basket analysis has got application beyond retail. I am not enumerating here because they are huge scope there. Few examples, like say medical example. Usually patients have one symptom followed by another. So if you can see one symptom, what will be the next symptom, or so that you can proactively address the disease. Then financials, say for example customers with mortgage accounts usually found to have also savings bank account. Okay, so good financial package developer actually will keep this into account so that a good strategy can be developed. Now the rules that actually are discovered using MBA are generally can be categorized into three classes. One is actionable rules, and in which actually we, the business analyst, will be more interested. There are trivial rules and there are some rules which are inexplicable rules. Let us have a look at what are actionable rules. Actionable rules are like this. For example, it has been found by studies that Walmart customers who purchase Barbie dolls, 60% of the cases they also purchase some types of candy bars, right? So there is a good association between the Barbie dolls purchase and the candy bar purchase. This is really an actionable items or actionable rules, because you can make a good association and you can make a good package by suitably bundling this kind of products. Trivial rules for which you do not need any analysis are something like that. Customers who purchase large applications are very likely to purchase maintenance agreement. So for this we really do not need a deeper analysis. So these are trivial rules. And there are certain rules which can be discovered, but there cannot be any logical coherence, logical explanation between why such rules exist. Like when a new hardware store opens, one of the most commonly sold items is toilet bowl cleaners. There is, even though you can discover this kind of rules, these rules do not have much business implications, and that's why they are in. So our target will be focusing on the actionable rules, so that we can leverage on these rules to get our business, better business returns. Now, I will get into the subject now in a more deeper way. For that, I need to show you how a transaction data base looks like. Okay, so ideally a transaction database should look like consisting of this kind of columns, where there are transaction numbers. Each transaction has got an ID or number. Then what are the items which are bought or purchased under that transaction? So item 1, item 2, item 3, item 4, there can be a number of items. And then there is a customer number. So each transaction is associated with each customer, different customers. Customer's age, customer's income, whether the customer has got a saving account, whether the customer has got children, and whether there is a mortgage. So some of the information might not be available. More information that you can extract out of the customer, better you can make an analysis. But some of the information will be absolutely essential, at least the items which the customer is purchasing, so that we can make whether there is any association between those kind of items. Okay, so we are now getting into association rules in much more illustrative way. There are some imaginary transactions which are shown here. So transaction 100 to 104, and each transaction has got certain items, and we would like to go for finding rules whether if customer purchases product X, whether the customer also purchases, same customer also purchases product Y or not. So this is illustrated like this. If buy diaper, then buy beer, whether this is valid or not. Shoppers who buy beer and diaper are likely to buy cheese and chocolate. So we illustrate this by this. There is a rectangular box in the left side. If buy beer and diaper, then there is an arrow pointing towards the right, then with a clause then, and then we have got another rectangle where we show which of the items the customers are likely to buy if they buy this. Okay, so buy cheese and chocolate. Now these are all illustrative examples. I am not saying that these are real world, but we are trying to catch the real world information this way. So given a transaction database, we want to mine or extract whether this kind of rules exist, that whether if I see customers buying diaper, whether most of them are also buying beer, so then I will say there is a one association rule. If I see the customers buying beer and diaper together also but purchase cheese and chocolates, then I will say that there is another association rule. So the association rule in a format wise looks like this. There is a set of items in the left side, and set of items in the right side, and they are associated with the clause if then. So if set of items in the left side are purchased, then most of the cases set of items in the right side are also purchased. Okay, so we say in technical terms LHS implies RHS. Now whether we should go for all such rules extraction, and I will say claim that whether we claim that all these rules exist. No. For an association rule to be properly established, we must satisfy certain specific criteria. And what are those criteria? Let us have a look at that. Say for example, we have got a transaction database in which we find that 2 out of 200k transactions, we find that milk and wine are purchased together. Should we say that there is an association between milk and wine? Of course not, because even though they are associated in 2 transactions, they are occurring only in 2 out of 200k transactions. So their frequency of occurrence is too less. So first question that comes to our mind, how to take into account the frequency of such occurrences, and for that we define a term called support. Okay, the frequency in which the items in the LHS and the RHS occur together or co-occur, this is defined as a support. So the support of the diaper arrow beer in this example is 3 by 5, because you will see that out of the 5 transactions, in 3 transactions we see beer and diaper are occurring together. Okay, they are highlighted with red color, you can clearly see. So 60% of the transaction contain both the items beer and diaper. So support for beer and diaper, this diaper arrow beer, this rule is actually 60%. You can also say beer arrow diaper, because in this case we really do not know who is influencing whom. We only see that both of them are getting purchased together, and they are getting purchased together in 3 out of 5 cases in the transaction database. So we find what is the percentage and we claim that as a support for that kind of association. Now whether support analysis or support evaluation is enough, obviously not, and this I illustrate by a very beautiful example, imaginary example again. My friend Bill, an 85 years old man, told me a joke in a past in the party last Friday. An old man is celebrating his 103rd birthday, okay, and he is saying, I will hold my 104th birthday next year. You are all welcome to join me, he announces in the party. How do you know you will still be alive then? One of his friends asked him. Now what is the justification on the part of the old man? Because very few people died between the age of 103 and 104, he replies. Obviously, you see, the logic of the old man is surely fallacious. Why? And that will enable us to understand that why support is not the real, only measure, right? The old man logic is probability of 103 plus and died is low. So 1 minus probability of 103 years plus and died is obviously high, because this is a complementary probability. But what he is forgetting is that probability of 103 plus died actually is probability of 103 plus and then probability of died given that the man was 103 plus. Now this is surely low, but this low is because of this low, not because of this low. This is high. And he is claiming that this is low, so I will be alive 104. This is definitely very high, but this is low. A person remaining alive till 103 years is very low. Obviously, the product is also low because that factor is low. So this factor is also low. Whereas he is claiming that this factor is going to be low because this factor is low. Obviously, you know that this kind of fallacious argument can lead to a lot of erroneous conclusions. So the law of this is due to probability of a person remaining alive till 103 years and not because probability of dying after 103 years, which is still very high. Okay. So now what are the escape or what are the remedy for these kind of problems only using support. We need to bring in most measures. One of the measures is called confidence. What is that? Now, is beer leading to diaper purchase or diaper leading to beer purchase? This question we have to answer. Okay, this question needs to be answered because support did not distinguish between them. Support only distinguishes that how many cases they are together. Now, if we look at this transaction once again, the transactions with diaper 100% have beer. You can just have a look. Wherever you have got diaper, there is a beer occurrence. Okay? But among the transactions with beer, only 75% have diaper because we see that 1, 2, 3, 4 beer transactions are there. Out of that, one does not have diaper. So 75% of the cases where beer is occurring, diaper is also occurring. But 100% of the cases where there is diaper occurring, beer is also occurring. So we want to get a deeper insight of this fact and develop a measure called confidence. What is that? Number of transactions containing both LHS and RHS divided by number of transactions containing only the LHS. So if we go by this definition, confidence rule for or confidence measure for diaper and beer is 3/3 because in all the cases wherever there is diaper we have got beer, so 3/3. So when diaper is purchased, the likelihood of purchase of beer, at least so far as these transactions are concerned, is 100%. Whereas confidence for beer and diaper is actually 3/4 because 3 cases we find that beer and diaper occurring together where we are finding beer is there. So this is 3/4. So you can see, so far as the confidence measure is concerned, the rule diaper and beer is more stronger than the rule for beer and diaper. So this is one insight that we have to keep into account, take into account. Then another rule, another measure that comes into action, that is called lift. And why this is required? Let us have a look at the transaction database once again. What are the support and confidence for the rule chocolate and milk? Okay, you can see support is 3/5 because 3%, 3 cases we have got milk and chocolate together, 1, 2 and 3 out of the 5 transactions. So support is 3/5. Whereas confidence, chocolate and milk is 3/4 because you see that milk and chocolate are occurring 4 times, 1, 2, 3. 3 cases they are occurring together, whereas chocolate is occurring 4 cases. So we have to go back to the definition of confidence. Number of times they are occurring together divided by number of times the left hand side is occurring. So this is 3/4. Now very high support and confidence, there is no doubt about that. 3/5 and 3/4, good support and good 60% and 80%, 75%. But then the real question is, does chocolate really lead to milk purchase? This is a question in which the analyst will be more interested in. Answer will be no, because milk occurs in 4 out of the 5 transactions. See, when chocolate was not there, alone milk is occurring 4 cases out of 5. So its support originally was 4/5. But once we brought in chocolate, its confidence went down to 3/4. So we call this measure as lift, that confidence, new confidence divided by original support, and this measure gives us whether introduction of the new item whether it has increased the sales or the consumption of the previous item. If it is less than 1, it is decreased. If it is more than 1, it has enhanced. So we want actually lift to be more than 1. So what is then lift doing? It measures how much more likely is the RHS given the LHS than merely the RHS itself. So we have got one product X and we have introduced another product Y. Okay. Now Y was originally having some consumption rate. We brought in X and we want to see whether the consumption of Y has increased or not. If it is really so, then X is working as a positive catalyst to me. So I will introduce this rule. If it is not so, If y is getting down because of x, then this is not an answer, and then will not say that the association rule is really good, because this association is really decreasing or dampening the consumption of y. So we want to find those rules where the lift is more than 1. For example, here you can see another example has been given. The total number of transactions, suppose in a database is 1000, number of customers buying diaper is 200, number of customers buying beer is 50, and the number of customers buying diaper and beer together is suppose 20. So we can see now frequency of beer, which is just a support, original support, 50 by 100, that is 5%. Confidence is 20 by 200, that is 10%, and lift is 10% by 5%, which is equal to 2. So that gives us a real insight that introduction of diaper actually has increased the consumption of beer. Do not think that this is a real world example I am giving. I am just giving imaginary example. So diaper, beer, these are just widely chosen items, but just to illustrate that lift equal to 2 is a good sign. So lift higher than 1 implies people have higher chance to buy to beer when they buy diaper. Okay. So we have introduced these all concepts, support, lift, confidence. Now how in real world these association rules are extracted, because only when we can really efficiently and effectively mine association rules will be able to implement market basket analysis. Now there is a standard algorithm called a priori algorithm, which is due to Rakesh Agarwal, Ramakrishnan Srikant, similar work that they did in the year 1994 in the world's most leading conference in this area, that is called Very Large Scale Databases. Is going to be held in September this year in India. That is a prestigious event in Delhi basically. So that VLDB conference, they developed, presented their work. First algorithms for mining association rule in large databases, where actually they proposed the algorithm a priori. The a priori algorithm is simpler, but handling it in a large database is a bit difficult task. I will show that how that is done. The association rule problem was defined to generate all the association rules for which we have got a support greater than a threshold minimum value. We have got confidence which is greater than a specified minimum value of threshold, and the base algorithm of a priori uses support and confidence, but we can also use lift to rank the association rules. So essential parameters are basically support and confidence, but lift is used in ranking. So those are the rules which are getting passed by satisfying the minimum criteria for support and minimum criteria for confidence. They are finally ranked in order of their values of lift, because you know that the lift is a final parameter. Okay, so you can think of ranking of the candidates which are passed the test, something like that. So the algorithm performs an efficient search for the data to find all such rules, and efficient search is the most important keyword, which I have no time to discuss, but you can go through this particular paper to understand how the searching has been made efficient. Now introducing all these fundamental concept, what is association rule, how market basket analysis is done, I am just concluding this talk by discussing how this particular aspect of extracting association rule is handled using one of the most popular software in statistical analysis and business analytics and data mining, that is R. Now R has got a library called A rules, which stands for association rule. So whenever you have to carry out any extraction of association rule kind of task, you need to have that library installed. Inside a rule package, the a priori function with all optimizations and enhancement has been developed and installed there. So the executable is there. A priori function is used to mine the association rules. The function a priori has to be supplied with the following mandatory parameters. We of course have to first make R understand which data set contains your transaction information. So we have to pass that as the first parameter. Then you have to pass also the threshold value of support. I have already said that primary requires what is the threshold value of support. You have to also pass the threshold value of confidence. The value of lift will be automatically computed, and the ranking of the rules will be done based on the value of the lifts. So this is all about, mining association rules from our large scale transaction database for identifying which are the products which are associated, which are the items which are strongly associated, so that you can take up appropriate strategy for formulating your business plans, promotion plans, advertising plans, product bundling. So many things can be done. Now, keeping the importance and ever-growing need for analysts for this developing strategies using association rule mining, Calcutta Business School is organizing a 2-day management development program on data analytics in supply chain and retail operations, where along with mining association rule we will also see many other practical techniques and theoretical frameworks which will be useful for designing and analyzing next generation supply chain, next generation retail stores, retail operations, not only from the end customer's point of view but also from the business point of view. For that matter, you can contact this email ID, Mr. Prof, who takes care of the MDP and other programs from the behalf of the Calcutta Business School. His mobile number is also there. And with that, I would like to conclude my talk on this particular topic. Thanks for listening and hope to see you in the program. Thank you very much.